welcome to this explainer. Okay, let's dive into this immediately, because today we are tackling an absolute beast of a topic. We're looking at the Cambridge Computer Science Challenge, and specifically, we're zooming right in on the 9618 syllabus. Today, we are decoding indirect addressing. Now, I know, it's a topic that literally terrifies candidates. But listen, by the end of this session, you are going to see exactly how to deconstruct these questions and secure those top-tier marks. We aren't just talking about textbook theory here. We are talking about the exact, battle-tested exam strategy you need to build bulletproof arguments with stress-tested evidence. So let's get right into it. So first things first, why do students struggle so much with complex binary representations? It's a notoriously tricky area, right? Well, to understand why marks just seem to slip away, let me introduce you to two sample students. We see these exact types of students in almost every single exam series. First up, we have Alex. Now, Alex is brilliant at memorization. When faced with an indirect addressing question, Alex just fact dumps every single thing they know about the CPU, memory buses, binary, the whole shebang. But there's zero analysis. It's just a wall of facts. Then we have Sam. Sam actually understands the concepts really well, but Sam rushes. Under the pressure of the ticking clock, Sam completely misses the specific command words hidden in the question prompt. Does either of these sound like you? Honestly, both Alex and Sam are working really hard, but they're leaking marks all over the place because they don't have a systematic approach to handling the complex data right in front of them. Here is our roadmap for today's explainer. We've got 5 quick steps. Number 1, the challenge. Number 2, the core principles and strategy. 3, the transformation. 4, an interactive workshop. And finally, number 5, the final examiner system. Let's kick things off with Act 1, the indirect addressing challenge, and specifically where students go wrong. To understand exactly where those crucial marks are lost, we really have to recognize that indirect addressing is inescapable. I mean, it appears in literally every single examination series. Examiners absolutely love it because it forces you to trace multiple steps. You aren't just grabbing a piece of data. It's like a giant puzzle. You're going to a base memory address, fetching the data stored there, and then realizing, wait, that data is actually just a pointer leading you to yet another memory location where the final operand is actually stored. It's a lot to keep track of. Now look at the screen. On the left, we have Alex's flaw. It's a massive paragraph of raw computer science facts, a total brain dump. But it doesn't actually analyze that multi-step mechanism. There's absolutely no evaluation happening. On the right, we see Sam's flaw. Sam's answer is super brief, but Sam completely ignored the command word, which was evaluate. Sam just described the process instead of weighing its pros and cons. I can tell you right now, the examiner's red pen is going to cross right through both of these. Knowing the binary conversion is only 50% of the battle, guys. Knowing how to structure that knowledge is the other 50%. Moving right along to Act 2, mastering the core principles and strategy. Here's the thing you need to realize. Indirect addressing does not exist in a vacuum. It is a theoretical architecture that connects to arrays, pointers, and memory management. In fact, principal examiner reports explicitly state that candidates who reference these cross-topic connections achieve significantly higher marks. It's a real game changer. The top students, they don't just say, oh, indirect addressing uses 2 memory lookups. No way. They explain the causal relationship. They explain how fetching a pointer from one address to locate the actual data at another allows a program to allocate memory dynamically, or how it handles arrays effectively. This brings in that systematic analysis and evidence-based reasoning that examiners are actively hunting for. Cambridge is actually targeting 3 distinct cognitive domains here. First up is knowledge and understanding. Simply put, can you define the mechanics of indirect addressing? Second is application. Can you trace a binary value through a specific multi-step memory table without getting totally lost? And third is analysis. Can you evaluate exactly why this mode is better than direct addressing for a dynamically changing scenario? You absolutely must hit all 3 of these domains to secure the highest band of marks. Before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, welcome to Act 3, the transformation. Let's apply this procedural framework. Let's look at how this builds the perfect algorithmic thinking process. There are 4 essential steps you need to drill into your head. 1, decompose step by step. 2, select appropriate data structures. 3, implement efficient code. And 4, test rigorously. This exact logical progression is the absolute foundation for computer science exams. And honestly, it doesn't matter if you're tackling the advanced 9618 syllabus or building your foundations with the codes like 0417, 0478, 0983, 0984, or 2210. Whether you're extracting from binary representations or drawing evidence-based conclusions, you have to break the problem down. Think back to our friend Alex. When Alex finally applied step 1, decomposing the problem, that massive wall of text suddenly became a targeted, precise set of steps tracing the pointer to the operand. And when Sam applied step 4, rigorous testing, they suddenly realized, oh wow, I didn't actually answer the command word. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at Ace the Exams _IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's get our hands dirty. Act 4, Interactive Workshop. We are diving into critical algorithm analysis. Let's dive right into Challenge 1, the data scan. I want you to imagine a complex table of memory addresses and binary values just pops up on your exam paper. You've got a 60-second timer to extract the core trend, identify the base address, find the pointer, and follow it all the way to the operand. So the crucial point here is that top-scoring candidates don't just find the right binary number, they evaluate the algorithm's quality. If the command word asks you to evaluate an indirect addressing implementation, you absolutely must analyze specific trade-offs. For example, time complexity increases because indirect addressing requires multiple memory fetches. You're first getting the pointer, then you're fetching the actual operand. You also have to discuss space complexity and memory usage trade-offs. And critically, this is huge. You must check for edge cases, what actually happens at the boundary condition limits. Acknowledging these limitations is quite literally what separates an A from a C. Let's jump into Challenge 2, Find the Flaw. Take a look at these two statements on the screen and compare them. The vague answer says, indirect addressing uses pointers. Well, it's not strictly wrong, but let me be clear, it is going to score 0 marks at this level. Now consider the specific technical detail on the right. Indirect addressing uses the address field to point to the memory location containing the actual address of the operand. Boom. Hit the nail on the head. That is exactly what the examiner wants to see. It shows a precise causal relationship. If you are writing that first sentence on your exams, you are losing marks simply due to a lack of technical vocabulary. And this brilliantly illustrates the principal examiner's top 3 warnings. These come straight from the official reports, guys. Warning 1. Answers are far too vague, lacking specific technical details. Warning 2. Students completely forget to check boundary conditions in edge cases. Warning 3. Answers are generic, totally ignoring the specific context given in the question. To beat this, let's use a super quick memory hack. Remember the acronym SEC: specificity, edge cases, context. Before you move on to the next question, I want you to stop and ask yourself, is my answer specific? Did I check the edge cases? Did I link it to the context? SEC will literally save your grade. Now for Challenge 3, Speed Writing. You have 30 seconds to write a perfect analytical paragraph. But as you practice this, I want you to burn this quote right into your brain. Even if your final answer is wrong, method marks can save you. This is an official examiner alert. You wouldn't believe how many students try to do complex binary tracing entirely in their heads. They write down one final incorrect number, and boom, score 0. If you show you're working, if you physically write down the step-by-step decomposition of exactly how you followed the indirect address, you can secure almost all the method marks even if your final arithmetic is slightly off. Seriously, show you're working. We've made it to Act 5, the final system and principal warnings. Let's bring it all together. Here are your 3 golden rules, the ultimate cheat sheet. Rule 1, command word decoding. You should never ever start writing until you know for sure if you are stating, explaining, or evaluating. Rule 2, Peel framework application. Structure your technical knowledge using point, evidence, explanation, and link. That is going to ensure your analysis is totally airtight. Rule 3, time management matrix. Allocate your time based strictly on the marks available and never leave a calculation without showing your step-by-step working. If you follow these 3 rules, you are guaranteeing that you are playing the examiner's game perfectly. So, what does this big number 2 represent? Well, it represents the average grade boundary improvement we see. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. It takes active, repeated application of that Peel framework and the SEC memory hack to successfully rewire your brain's algorithmic thinking. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams _IGCSE to excel in your Cambridge examinations. Subscribe right now to at AceTheExams _IGCSE and click that bell. Don't let another exam pass you by. Also, drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here. I'll leave you with this final, provocative thought to ponder as you gear up to tackle your next past paper. If your algorithmic logic fails at the boundary edge case, does your memory address truly hold the right answer? Remember, in computer science, precision is absolutely everything. Keep practicing, keep evaluating your trade-offs, and I'll see you in the next explainer.